Pictures
Yeah,
we
sure.
can install on rooftops, agricultural rooftops. We can install over crops, and we can install over greenhouses, which is very popular in Israel as well.
That's sure.
But we also do normal installations on the ground, on normal rooftops, concrete rooftops. So it's very flexible. We can install basically anywhere, and it's a simple. Here, I think it's moving.
Yeah, it's moved.
See, it's moving.
It's moved by. It has a sensor which actually indicates where the sun is, or you just move it.
No. So there's. It's a complex algorithm. The basic algorithm is the sun every day does the same. Different throughout different seasons. It's different, so it tracks the sun. But there's a lot of times where we have to add extra pieces to the algorithm. Like if it's very windy, the structure can be damaged. So we go into a safe mode. If for example, if we have like weather forecasting on every site. We have sensors on the site and satellites for forecasting, so we know that if it's going to be cloudy, then it's better to be flat.
Yeah,
if it's
sure.
cloudy, just because of the sunlight, it's better that way. But and then if it's going to be not cloudy in 15 minutes, then we can start to rotate because we forecast the weather. So that way we produce more energy. There's also, if it's raining, we might want to, and it's cloudy, there's not a lot of sunlight, we might want to help clean the panels. So we'll put them to the angle so that the water will run off the panels and clean them, things like that. Yeah.
Mm-hmm. Does it work with any type of crop?
Any type of? So the answer is yes, we can do it over any type of crop. The biggest difficulty is really the models of how we balance because the panels need to share the sunlight with the crops, and every crop is very different. So we have like vineyards in where they grow grapes, and there it's like they don't need a lot of sun. So currently plants that don't need a lot of sun, it's easier because the panels can shade. But when you have crops that need a lot of sunlight, then it can be much more difficult. But it's all a matter of telling the system what it needs, and then we can plan accordingly, meaning that if the crops need 6 hours of sunlight, we can set it up that they'll receive exactly what they want, and then the rest of the day will be at the optimal angle for producing electricity.
When it comes to in windy areas, is there a problem with the solar?
No, so we have installations in India, for example, where there's monsoons. It's very, very, very windy, and it's fine. If it's really windy, we can add extra reinforcement, and it depends on where it's installed. So if it's a really windy place, we'll put a little more steel. It's a little more expensive, but it can withstand winds that are very strong.
So how much does it produce, let's say?
It totally depends where. Kenya has a lot of sun.
Yeah, sure.
But even within locations in Kenya, it can be very, very different. We had a project that we were looking at in Europe where one project was here and then there was another project 15 kilometers away, and the production was very different. Just because the altitude, the angles, it's hard to answer. It really depends on the site.
So the altitude also comes when it comes to the
What do you mean?
The altitude.
The altitude affects the amount, the irradiance, like the strength of the sun. But and also the angle. If it's on a slope, there's a lot of factors. But it's better to think of it as that if you had a fixed tilt, and versus a tracker, the tracker can produce 15 to 25% more energy, and in Kenya it would be closer to 25%. So it's a lot. It's a lot more energy.
Let's say I need to use the solar energy for pumping water from, let's say, 2 acres. How many panels does solar panel?
To pump water, it depends on how much water, how big the pipe is.
6,000 liters per hour.
It depends. These panels are about 535 watts, so you can calculate based on that and the needs of the pump. Every pump is different, but it's definitely very popular. We know to do. You have to have solar pumps for water. It's very popular, and we can do it. One thing that's very relevant is that if you have an agricultural setting out in a place that isn't connected to the grid, right? The tracker has a little battery in it, so that it can be self-powered, meaning that at 12 o'clock there's a lot of energy, so it charges the battery, and then at night when there's no energy, you can still move the tracker back for the right position in the morning. Or if it's windy at night, it can go to the right angle. Or if it's raining, it can go like this. So there's a little battery, so it charges itself, meaning it doesn't need to be connected to the grid.
Do you have any outlets in Africa?
We don't have anything installed yet in Africa. We have a project that we're working on in South Africa. That's the only one. We talked to some people in Egypt, but that's it. Nothing built yet. We've built in India and a bunch of places in Europe and in the United States.
When it comes to the solar energy, you can also use it in parking.
In
Because cooling.
the parking. Yeah. We haven't done parking. Parking a lot of times isn't that good for trackers because there's all sorts of regulation. It needs to be sort of strong and a lot of steel. But we can do it, but we haven't yet. We've done mostly on the ground and on roofs. Greenhouses.
How much
It depends on. The biggest cost is the steel. So, like you can see here in the picture, you can see like, if you put it over you need a lot of steel because it has to be very high. It also depends on the wind, how much steel but it's not that much more expensive than fixed steel. If you were to have a fixed steel panel, this system